welcome to my coronavirus classroom. I'm Janessa Jacobs, and you might be thinking your hat is ridiculous, to which I would say, only because it's situationally inappropriate, much like having an exam review in your living room. Ah, thanks coronavirus. Anyway, it's a ridiculous hat for a ridiculous way to have a review. So here we go, here are your questions. Ventilation refers to the A, movement of air into and out of the lungs, B, gas exchange between the blood and the tissues, C, transportation of oxygen and carbon dioxide in the blood, D, gas exchange between the air in the lungs and the blood, E, respiration at the cellular level. Ventilation refers to the answer is A, the movement of air into and out of the lungs. So if the question said respiration refers to, A would be included because that's part of it. Gas exchange would be included because that's part of it. Gas transport would be included because that's part of it. Gas exchange at the lungs and tissues would be included. So all of these first four answers are the processes of respiration. So if this said respiration involves, I would get rid of the E choice and instead say all of the above, and all of the above would be the answer. But it doesn't. It just says ventilation, or pulmonary ventilation is this first part, one process of respiration. Okay, the lymphatic system plays a role in maintaining fluid balance within the body by A, adding lymph to GI tract secretions, B, returning interstitial fluid to the blood, C, transporting lymph from the tissues to the liver, D, carrying excess fluid to the kidneys to be excreted, E, actively absorbing fluid from the blood. So the lymphatic system plays a role in maintaining fluid balance within the body by what? Oh, you're right, B, returning interstitial fluid to the blood. So if you recall when we talked about capillary exchange, 100% of whatever got pushed out on the arterial side got pushed out, but only 85% got picked back up on the venous side. The remaining 15% then is then returned from the interstitial space to the blood through which structures? The subclavian veins. Okay. A protective function of the respiratory system would be A, altering blood pH by changing blood CO2 levels, B, olfaction by drawing molecules into the nasal cavity, C, producing ACE, which helps regulate blood pressure, D, preventing microorganisms from entering the blood. A protective function of the immune system. So this is the way that our systems integrate. And the answer is D, preventing microorganisms from entering the blood. So if you recall, the part of the second line of defense are your mucous membranes, and your respiratory tract is covered in mucous membranes, which helps to prevent the entrance of stuff into your body. Okay, structurally, structurally, lymph vessels are most similar to A, veins, B, arteries, C, arterioles, D, capillaries, E, venules. So this is asking about lymph vessels, like if you're thinking of collecting vessels. And they're most similar to veins. Why? Well, they've got a valve in their innermost layer to prevent the backflow of fluid. That's the biggest distinction. If you think about arteries and arterioles, they have pretty thick muscular layers. They're going to be really responsible for resisting blood pressure. So really the best answer is A, veins. Okay, which of the following is not a process of respiration? A, voice production, B, systemic respiration, C, ventilation, D, respiration, E, transport of gases in the blood. Oh, you're right, I already told you the answer because we just talked about what all the processes of respiration are. So the one that is not is voice production. So sure, you could say a function of the respiratory system is to give you voice production, and that's because your larynx vibrates your vocal folds to produce sound. So sure, that's a respiratory system function, but that's not a process respiration. Recall, respiration is a four-part process that starts with pulmonary ventilation, continues to alveolar gas exchange or external gas exchange, then we have gas transport, then we have systemic gas exchange or internal respiration. Okay. Interferon production is stimulated by A, a viral infection, B, the complement cascade, C, antigen-presenting cells, D, degranulation of basophils, E, inflammation. Interferon production is stimulated by a viral infection. You're right. And why is it a viral infection? Because a virus-infected cell, when the virus hijacks its DNA, it's going to turn on our interferon genes. So interferons will be expressed by the virus-infected cell, and if you recall, they act as paracrine signals that signal the neighboring cells and cause them to upregulate their antiviral properties. Which of the following is not a function of pseudostratified ciliated columnar epithelium in the nasal cavity? A, it traps dirt and removes it from the air. B, it moisturizes the air. C, it exchanges O2 and CO2. D, it warms the air. What's not a function? You're right, it's C. The exchange of gas is not a function of the nasal cavity. The exchange of gas happens only in the respiratory zone, which are the teeny tiny little respiratory bronchioles and the alveoli hanging off of them. All of the rest of these things we see here are things that occur in the nasal cavity, and it's part of like this trapping of dirt and debris. That's part of the innate kind of immune thing. The moisturization and the warming of air, we call that conditioning the air to get it ready to enter your respiratory tract. Okay, the inflammatory response. A, prevents the spread of an infection. B, stimulates erythrocytes to leave the blood. C, delays healing of damaged tissues. D, depresses immunity. E, is harmful and should be immediately reversed. The inflammatory response. I'm actually glad we have this question because I don't know if I made a big enough deal of this. It prevents the spread of an infection of all of these. These are all just distractor answers. So an inflammatory response does not pull erythrocytes from the blood, it pulls leukocytes from the blood. An inflammatory response increases the healing in our damaged tissues by bringing our white blood cells to the area and by causing damaged cells in the area and are going to, and like in our connective tissues and things, our resident mast cells and things are going to release chemicals that all help to set the stage for healing. So that's not it. I wouldn't say it depresses immunity. We're going to get our white blood cells there, which is going to help if need be. And it's definitely not harmful and shouldn't be immediately reversed. It's harmful if you have long-term chronic inflammation. I'm convinced that disease, death, and aging are due to long-term harmful inflammation. But it shouldn't be immediately reversed. It's doing some important things. And one of the things that's happening is we're containing the little potential pathogen that could be entered right to the area. We're wrapping it up and kind of just localizing the response right here. We're getting blood cells, white blood cells right there so that our macrophages can get there and start gobbling stuff up. Neutrophils will usually be the first to arrive. They're the highest concentration in the blood, so they'll get out there, and they're antibacterial. There are bacteria all over your skin. There are bacteria all out in the world. So if you get a cut, there's a great chance the bacteria is going to come into your body through there. So neutrophils will be able to go to the scene and gobble up the bacteria. So we can localize it. The other thing that's going to happen is since we have all of the localized or all of the blood vessels in the area that are not like actually bleeding are vasodilated, we're bringing a lot more fluid to the area, so we're going to produce this exudate that's going to wash the wound. And when that happens, then we can bring activated macrophages. In that they can become antigen-presenting cells. We can bring all of any bacteria. We can wash that all into the exudate, it's called, that's going to wash into the lymphatic capillaries that converge to become lymphatic vessels that are going to run past our lymph nodes. And so then there in the lymph nodes, those macrophages can become antigen-presenting cells and activated helper T cells so that we can start getting an immune response going. The bacteria then can bind to B cell receptors, cross-link the receptors, get a B cell activated, and we can really get a humoral immune response going. So inflammatory responses are great, and that's the correct answer. Okay, which of the following statements concerning the lungs and the pleura is true? A, each lung is suspended by a separate pleural cavity. B, parietal pleura covers the surface of each lung. C, the space between the visceral and parietal pleura is called the mediastinum. D, the pleural fluid assists in gas exchange. E, the pleural membranes adhere but cannot slide past each other. So which statement is true? Oh, A is true. Each lung is suspended in a separate pleural cavity. They each have their own pleural membrane. The parietal pleura lines the thorax. What's the name of the layer of the pleural membrane that's in contact with the lungs? As in all serous membranes. The visceral layer, you're right. Okay, the space between our pleural membranes is the mediastinum. And the mediastinum is the serous membranous partition that covers the great vessels of the heart and the pericardium. So that's in between our pleural membranes, but not in the space between the visceral and parietal pleura on one side. The space between the visceral and parietal pleura is the pleural cavity, and it's full of pleural fluid. Okay, pleural fluid assists in gas exchange. No, it doesn't. That's a distractor, and they do slide past each other. Okay, primary lymphatic organs include the A, tonsils and spleen, B, thymus and lymph nodes, C, red bone marrow and thymus, D, red bone marrow and lymph nodes. Primary lymphatic organs include so those are all the things directly involved in the production and maturation of our leukocytes, so the answer is C. Now because I read it, it might have made it more obvious, but if what you're doing is taking a test and you just see like your first primary organ and stop reading, then you might choose B. Some people do that. They're like, oh, the thymus is a primary organ, so B must be the answer. The lymph nodes are not primary organs, they're secondary organs. The other primary organ is the red bone marrow, and we have that as a choice right there. Okay, contraction of respiratory muscles causes the movement of air out of the lungs in quiet expiration. True or false? Contraction of respiratory muscles causes the movement of air out of the lungs in quiet respiration. The answer is false. When the diaphragm contracts, it pushes down on your abdominal organs. The external intercostals help to lift out on your thorax, and what that's going to do is cause air to move into your lungs. So air moving out of your lungs is due to relaxation of our respiratory muscles. Okay, once cytotoxic T cells are produced, which of the following is or are consistent with their ability to attack intracellular viruses? A, most nucleated cells produce antigens through the MHC. Whoa. Okay. Once cytotoxic T cells are produced, which of the following is or are consistent with their ability to attack intracellular viruses? A, most nucleated cells process antigens through the MHC class 1 mechanisms. B, viral antigens are processed by the MHC class 1 mechanism and are presented to the cell surface. C, cytotoxic T cells bind MHC class 1 process antigen. D, all of the choices are correct. But oh no, they're all correct. Okay, most nucleated cells can get sick, so they're going to be able to process and present antigen in MHC1. Viral antigens are presented in MHC class 1 mechanisms and presented to their cell surfaces. The cytotoxic T cells are going to bind that and recognize it. What part of the cytotoxic T cell binds that? Ah, it's CD8 protein, right. Okay, what type of alveolar cells produce surfactant? A, ciliated simple cuboidal epithelial cells, type 1 pneumocytes or type 1 alveolar cells, type 2 pneumocytes, type 2 alveolar cells. T cells. B, when activated, become plasma cells and produce antibodies. C, are responsible for forming all the body's memory cells. D, suppress the activity of T cells. E, mature in the thymus. B cells. Yeah, they become plasma cells and produce antibodies. What do antibodies do? They can neutralize an antigen by covering up all its epitopes. They can agglutinate large antigens by clumping them all together. They can precipitate small antigens by clumping them all together. They can stick a complement protein to the fixed region, so complement fixation, which is then going to enhance inflammation and opsonization. Alright, if you get bit by a black widow, you will need to go to the emergency room for antivenom. You will be getting blank immunity that is blank. You will be getting A, natural immunity that is active. You will be getting B, natural immunity that is passive. You will be getting C, artificial immunity that is active. Or you will be getting D, artificial immunity that is passive. Alright, you're right, it's D, artificial and passive. And it's artificial because the antibodies you're getting aren't made by your lymphocytes. We made them in some like horse or something and then suspended them in their blood, pulled them out and gave them to you. The passive part is because you don't have time to form those antibodies. We're not actively forming lymphocytes to make antibodies that can protect you. So just remember these things overlap. You can't be just one. You can't be natural immunity. Okay, you encountered, you're getting this immunity because of nature, but why? Because you actively produce lymphocytes, because you caught a cold, or because you passively, I don't know, were being breastfed by your mom's antibodies. So just be aware of that. Alright, that wraps up the review. Make sure if you have any questions, you ask them during class time in your teacher helping students succeed discussion page. See you later.